Hey, how's everybody doing? I'm Swift. I'm here today to talk to you, yes, about Saturday morning breakfast cereal, or AKA hacking Arduinos in Python. So, if you've ever seen me speak before, you know that this obligatory slide is coming up. No, despite the handsome resemblance, I am not, in fact, Ryan Gosling. I am actually Swift. Uh, I used to be an evangelist for 2nd grade. I'm actually here representing them today because they were so kind as to offer to sponsor my trip here and pay for me to get to Toronto from New York to speak to you guys today about this. So big props to 2nd grade for doing that. These days I'm a free agent evangelist, which means I'm out working on my own startup and trying to figure out how to make developers' lives easier. I'm also one of the founders of Hacker League, which is a platform for people who organize and attend hackathons. If you've been to any hackathons in the past year, especially on the East Coast, you've probably used our software. We're running Music Hack Day down the street, which is awesome too. So Hacker League, yeah. And then I also am an open source developer. I write a lot of open source code, including Breakfast Cereal, which I'm here to talk to you today about. So, and you can find me on Twitter at SwiftAlpha1 if you like what I'm saying or disagree or whatever. So I'd love to hear from you. Well, let's talk about Arduino, right? That's what we're all here to talk about, and everybody's excited about Arduino. And because you're in this room, I'm assuming you already know what an Arduino is, but if you don't, it's a little open source microcontroller that lets us talk to different hardware components, so buttons, LEDs, sensors. It's like the meta layer between our computer and the real world. So how many people have an Arduino already? Okay, keep the hands up. How many people have made something cool with that Arduino that have their hands up? Okay, so I'm about to enable you to make some really cool stuff in a really short amount of time using Python, which we love. So developers are going cuckoo for Arduino. There will be no shortage of breakfast cereal characters in this presentation, in case you were wondering. So running Hacker League, being an evangelist, I kept going to hackathons, and I was seeing developers everywhere using this Arduino stuff, and it was like really catching on, and I would see it more and more. So I had to find out for myself what it was all about and why it was so awesome. So I really dug into it, and here, this is like a brief overview of some of the reasons that I think developers really like Arduino. So number one, it's such a simple API, right? Arduino makes it like seamless to actually interact with these microcontrollers. If you look back, 10 years ago, and you're looking to get into microcontroller development or like looking to find ways to talk to different physical components, there were no really simple APIs that were just readily available. Arduino and the proprietary language behind that has really abstracted away a lot of the difficult stuff when it comes to interacting with microcontrollers. And it's one of the key differentiating factors between like this and a Raspberry Pi is it's not like a fully fledged computer, right? This is literally just the microcontroller that lets us interact with these things. And it's really simple. It's the 18 mega. We'll get kind of into what's on an actual board in a second. It's based on open source, right? Like everything about this board is open source. The hardware, the software, the language that it runs, all of it is open source. You can literally go to GitHub, go to the Arduino GitHub user or GitHub organization, and like check out all this code and edit it and change it yourself. And that's why we're seeing so many of these like clones pop up. Like these Arduinos are available everywhere, but like you can make your own Arduino for like less than $1 these days, or like less than $5 maybe. But you can like buy all of the things that you need to make one of these at home yourself. So it's all open source. It's based on open source. It's awesome. And all the code that's out there that people are sharing is like open source too, because that's one of the founding principles. It's cheap. It's so cheap. Like you can go to Radio Shack and buy one of these things and a bunch of sensors for less than 30 bucks, right? So if you, in the process of experimenting, happen to like break an LED or break a button or whatever, it's really easy to go and replace this stuff because most of these components cost less than $1. So the fact that it's cheap makes it like great for prototyping and testing things out and getting our hands dirty like developers like to do. It's available everywhere. I was at Pi Ohio a few weeks ago. I didn't have everything I needed with me to actually do this talk, so I went to the local Radio Shack and bought another Arduino like minutes before my talk. But it's just, that goes to show you how available this stuff is, right? It's literally everywhere. You would be hard-pressed to go somewhere in North America that didn't have a Radio Shack or some other hardware or electronics store that didn't sell Arduino. And you can get it online in a million places too, and it's shipped everywhere. So it's definitely available. There's tons of examples. You can go to like Arduino CC, Adafruit, SparkFun, GitHub, Google, whatever. There's all of these Arduino examples that show us how to make these really cool hardware projects, and developers love sharing this stuff and reading about it. So it's really easy to get started. So for all those reasons, Arduino is great. And you probably wouldn't be here if you didn't agree with that, I would assume. But so what I want to do with this talk is I want to start at the very beginning. We're going to go through a really basic introductory hello world for Arduino, and you'll be able to go home and actually blink an LED yourself And then we're going to get into how you can use Python to actually do some even more cool stuff with it. So hopefully by the end of this talk, you'll be able to go out and actually buy an Arduino if you don't have one, or use the one you already have to make some really awesome hacks. So let's do Arduino 101 here. I've kind of highlighted in red the important pieces that are on a board. This is an Arduino Uno, which is the most common board, which is probably the one that you guys have. The number 1 is a USB serial port. That's what we're going to be using a lot today to talk to these Arduinos. It lets us do communication between our computer and the Arduino. Number 2 is the ground and power. If you don't know anything about a circuit, in order for a circuit to function, it has to go from one end to power through whatever electronic components you have, and then the other end up in ground. That completes a circuit, and that's what makes these things possible. Then we have the digital pins, and then we have the analog pins as well. Digital is 1 and 0, on and off. Analog is anywhere on a sliding scale between 0 and 1, or 0 and 255, depending how you look at it. We're going to be using both of those today, and we'll show you kind of how those work too. So let's do the basic hello world. In Arduino and hardware, hello world is blinking an LED. So the first thing you need is the IDE. You can go to arduino.cc and download this software. There's binaries for Windows, Mac, Linux. It has a ton of examples built into it, including a lot of the ones we'll use today. I'm not going to pop over the IDE to save some time, but you can go and look at these things. So to wire up an LED, what I have here is like a basic diagram of it. Arduino, like those pins that I showed you, the digital analog ones are numbered. So for digital, it's 1 to 13, and for analog, it's A0 to A5, I think. 13 happens to be right next to a ground, so we can literally stick an LED in the positive side in the 13 pin, and the ground side into the ground. Completes a circuit. Technically, this diagram has a resistor, but that's not really needed. You'll just probably burn out a couple of resistors like I have by not using it. This is the basic code to do it. There's 2 functions. There's a setup function and a loop function. The setup function runs once at the beginning when the Arduino is connected to power. The loop function runs continuously throughout the life of the program that you're running. So in our setup loop, basically we're setting a pin, which we define as 13, to output mode. Once we have it at output mode, we're going through the loop. We write it as high, which is on or 1 in the digital world. We sleep for 1 second. Then we write it as low, it's 0 or off, and then we come back around the loop, wait another second, and just keep going, right? So that's blink. So we can do that, but I think that we can kind of get the idea of what's going to happen here, and then we'll actually see it in real time in a second. So that's awesome. Like all of the examples you'll find are like that kind of C proprietary Arduino language. I can just imagine the Tricks Rabbit like running in here and being like, hey kids, prototyping with Arduino and in C is fun and easy, and you should totally do it. And the kids are always smarter than the rabbit in those commercials, and they're like, are you kidding me, rabbit? Like, why would we ever want to do that? Like, I'm a hacker. I want to prototype. And the thing is that friends don't let friends program in C, and this slide always gets a lot of attention. But the truth is, when you want to go out and prototype, like, there are languages and tools that you can choose from. And sure, you can choose C when it's the best one for the job, but when you want to write things that are quick and dirty, you want to use the languages that you know and love and that come easily and naturally to you. And for us as Python developers, or even if you're a JavaScript or a Ruby developer, like you want to use the scripting language or the language that you use on a day-to-day basis to do that prototyping. So it's not that I think that C is necessarily bad. Like I know that we need C to have C Python, right? But the idea of like just going out and prototyping stuff, like we want to find a better way to do that. So how do I, and like these are some common questions I hear, like how do I talk to the internet? Arduino gives us a library for that. Like the code for that actually looks like this. And I'm like, lol, like I don't want to implement a post request by hand. I don't want to have to worry about that. There's too much room for error. It's really hard to debug. We need an extra shield to either connect it to Ethernet or Wi-Fi. It's a lot of effort. There's limited horsepower. Like these boards can't really do too much complex processing. If you start doing that, like you're going to end up with either since it's a synchronous API on hardware, like you're going to end up like with timing issues, or you're not going to have enough memory to do it, or whatever. But it's like a very limited space. So if you want to do any complex processing, you have to pull it off the board no matter what. And then you're going to either be using serial or Ethernet or something for that anyway. So there must be a better way. Like it's too complicated to do anything cool in C and on this board and prototype it. So there must be an alternative way of doing this. So this is my feature wish list. In addition to all those things I mentioned at the beginning, cheap, simple, available, I would like to have these things as well. I want it to be language agnostic. I want it to be cross-platform. I want it to be able to talk to the internet easily, and I want to be able to do complex processing on the data that we're pulling in from whatever sensors. And so I did the thing that Toucan Sam would tell me to do, and I followed my nose to the internet. I found out about this thing, Fermata, which is what Breakfast Serial is based on. The idea with Fermata is it's an API, essentially, that you put on the board that lets us talk to microcontrollers over serial. So we would do something like send a byte that says, OK, pin 13, another byte that says write, and another one that says 1 or 0. And like the program that's running on the Arduino is interpreting those bytes over the serial cable. So what that kind of looks like in Python is this great library PyFormata that kind of implements that already. It's implemented by this guy, Tino. So essentially, if you look at it here, this is the same code as the hello world. We're connecting our Arduino to our computer. We're saying, hey, here's the serial port that it's connected to. We, again, go after that digital 13 pin. We write 1 to turn it on. We wait a second. We write 0 to turn it off. We wait a second. This is blink. It's exactly the same code, except this time it's written in Python. It's not written in C. So this is much better than the old code that we had, because now we're actually able to write this stuff in the language that we want to. We're able to do complex processing because it's pulled to the computer, and since it's on our computer, we can also talk to the internet, which is great. And there's all these libraries that do this in JavaScript and Ruby. And I was teaching these Intro to Arduino workshops. I did it at Heroku's conference Waza. I did it at a couple other smaller conferences. And I got asked to do it at PyCon US. And I said, yeah, sure, I'll definitely do that. Sounds great. So I'm at South by Southwest the week before. And I'm about to get on the plane to head to PyCon. And I'm like, oh, I really should look and see what the library is that does this stuff so I can teach this workshop. And I went, and I'm like, oh, my God, it doesn't exist. So I did like the natural developer thing, and I wrote it on the plane between South by Southwest and PyCon. I landed, deployed it, and actually taught the workshop with my new library, which is Breakfast Serial. So, and I'm going to give you an in-depth tutorial here, but I live debugged it then, and it got a lot of feedback, and I've been working with that feedback ever since. So to install it, pip install Breakfast Serial. If we want to take a look at the sample hello world that we had from before, this is exactly the same code, but this time, instead of having to have like define the serial port or worry about any of the connection stuff or writing high or low or any of that, we abstract all of it away into these really simple objects like Arduino and LED. And this is just that same hello world code, but now instead of it being either written in C or like 20 lines of Python, now it's only 5. So this is where we're going to do the demos. I have a couple of things with me that I'm going to show you, and then we'll kind of talk about like some of the design decisions that I made doing it. But I guess let's start with the demos. So if we pop over to a terminal, oops, that's not what I wanted. So we pop over to a terminal, which is not going to work, of course. So let me just drag this over here. Cool. So we now have our terminal. So we'll start by opening up a Python REPL. OK, so we'll start by importing Breakfast Serial. Of course, I can't see this. Sorry. Let me just mirror my displays. Cool. So we'll import from Breakfast Serial Arduino, a button, and an LED, maybe. Oh. Yep. Good call. So then we'll create a new board object, which is just an Arduino. This is going to figure out what serial port it is based on like a regex that is pretty commonly used. I'm actually going to make this bigger so everybody can kind of see. Then we can create like an LED, which is just simply an LED object attached to the board that we want. And this one is on pin 13. So now if I do something like LED.on, well, now the LED is on. And I'll kind of hold this up so everybody can see. Same idea here with the button. We can do like button equals a new button object on a board on pin 8. We can do something like button.down LED.toggle. So now whenever I click this button, we get a toggling LED. So it's like a light switch that we just made in 5 lines of Python, which is pretty cool. There's a couple other examples I have with me. So this one is a potentiometer. The idea here is the same. We create a board object. We have this analog sensor, which is not just reading 1 or 0. It's actually reading values on between 1 and 0. So as we listen to a change event from the sensor, whenever we get it, we change the brightness of the LED. And I'm actually just going to print out sensor.value so we can all see that too. So So if we actually run this again, it's going to connect to our Arduino just the same as before. I have the potentiometer here, and it's this big red LED, and we can kind of see that as I change it, the LED is changing, and we're getting new sensor values, which is really cool. So there's that, and then a much more interesting tutorial, which people tend to like, and I'm not sure if my audio is connected on my computer or not. We can do. So this one is a keyboard that I wrote, essentially. Oh, I guess I can pull up the code. So this is the same kind of idea where we create this Arduino object. We have 5 different buttons. Each one corresponds to a different sound. When we press the buttons, of course, the audio isn't working. So when we press the buttons, we get different sounds for each button. But this kind of gives you an idea of like, okay, now we don't have to worry about putting these sounds on the board. Now we don't have to worry about interpreting that kind of stuff. Like on don't have to worry about like installing a speaker or a buzzer, whatever it may be. We can just do all of it on the computer. We don't have to worry about writing anything in C, like really simple. And there's also additional components other than these things. There's servos, motors, analog sensors, whatever, right? So just these generic things. And the idea is to create simple API abstractions for each of these components that people commonly use to alleviate prototyping, like technical debt, essentially, making it easier for people to actually use these things. So to go back to our kind of slides here, let me unmirror. So this is our feature wish list from before. I would say that we probably definitely hit all those things. It's language agnostic because obviously there's libraries that do this in different languages. Specifically, the one we're interested in is in Python. That's great. It's cross-platform. Definitely can talk to the internet because it's being done on a computer. It can handle our complex processing. So I'd say we definitely accomplished those goals and passed that. So I made up this like little rhyme about all of the components, and I can imagine the Lucky Charms guy being like buttons, LEDs, and sensors, servos, buzzers too, lots of new components added by devs like you. So it is open source. It's on GitHub. It's github.com/theycallmeswift/breakfastserial. I'm adding components pretty regularly. Many of the components I come into contact with are like when I'm teaching these introduction to Arduino classes. So you'll find that they're pretty basic, but the ones that get added that are more advanced are from hackers who are building things at hackathons or in their spare time or whatever, and are adding these things. Essentially, you inherit from a base component class or a base sensor class, and then you add on the different functionality that you need for it. So if you're interested in this kind of stuff and you want more Arduino stuff, there's a lot of places to go and read about it online. Like a quick Google search will reveal like a whole bunch of information. If you're interested in Breakfast Serial or more of these libraries like this, obviously I'm talking about it here. I'll also be one of the mentors at RobotsConf, which is coming up in December in Florida, which is it's a conference focused on building robots using this kind of technology, using Arduino, Raspberry Pi, whatever. I'll also be speaking at Makerland, which is a maker kind of conference taking place in Warsaw. I'm also launching Arduino.io, which is an event listing website for Arduino and hardware hacking. So you can go there right now, kind of register for an alert when we actually go live. So that's kind of the basic introduction to Breakfast Serial. Again, I'm Swift Alpha 1 on Twitter. My name is Swift. You can find out more about what I'm doing and the other cool projects I'm working on at theycallmeswift.com. So let's open up for questions.
When it comes to working with stuff like OneWire and like DSC, like the digital clocks and stuff like that, how are you managing dependencies?
So the way that I did it is I have a monitoring thread that's actually just reading from the board. It actually spins up a separate thread. So any of the actual like clock cycles, are you talking about on the board, the clock cycles? Oh, the component stuff. Yeah, so there's like actually, if you use any of the methods that have a timer in the background, there's actually a timer thread running on your computer that's actually telling the board to do the changes. So if you do LED.blink and you give it like every 1 second, your computer is sending the command over the serial cable saying, hey, turn on or turn off depending on the state of the LED. I'm not actually managing any of that on the board. Like Fermata doesn't do that naturally. It's literally just for reading and writing.
I've developed a little bit with the Arduino just as a toy, and when you write a program, in the Arduino native IDE, you send it to the device, and then you can disconnect it, and your program is still running. So there's some sort of language, like it's compiled into something that the Arduino understands.
Yep.
And it looks like this is something that you simply don't support, and Pyformata simply does not support. You have to have the computer hooked up the entire time so that you can be communicating and sending those commands over live the whole time?
Yep. So it does need to be connected to a computer through some kind of serial protocol. You can do something like pairing it up with a Raspberry Pi to make it a lot more mobile. You could do something like pairing it up over XP, which is like over Wi-Fi. There's a lot of ways you can do it, but yeah, it needs a computer. And the main reason it needs a computer is to do like that kind of, the computer abstracts away all the difficult things to do on the Arduino, so like the internet or the complex processing or whatever. I mean, if you look at most of those, like the kind of things you're talking about where the Arduino operates independently without the computer, a lot of it is about just reading data and then sending it somewhere else to use it, just because like if they're connected to a battery or something like that, like it wastes battery to do processing on those things. But so yeah, this is, no matter what, you're going to need a computer to use this library. Right now it only supports over USB serial. There's been a lot of efforts for other libraries in different languages, removing it away from just USB serial into different protocols that would allow the same kind of thing. But yeah, right now you need the USB serial, and you'll always need a computer to do Formata stuff. And again, this is really geared towards prototyping. Like, I don't want anybody to like go out and make production software with this that needs to be disconnected from a computer, that needs to be like whatever, right? This is really for, I want to test out my idea really quickly with Arduino and prototype it. Like, there's a lot of advantages to writing code in the Arduino proprietary language and compiling it and putting it on the board, specifically speed, performance, reliability, kind of things like that. But this is like great for prototyping and like hacking out things that you kind of want to see if it would work.
Are there any other implementations of languages that compile into the Arduino native thing, like Python-like or something?
Sure. There's actually, I haven't seen any like that. I think there's a lot of potential there to create some kind of like abstraction language that compiles down to Arduino proprietary code. I haven't seen that. I'm sure somebody's working on that somewhere, and if they're not, then somebody needs to start working on that, because I think there's a lot of advantages that can come from something like that.
More question?
Just as a comment on what you just said, actually, the Arduino will compile to C and then assemble. You can actually write directly to C and have a make file that will go. That's what the Arduino IDE does in the background, so I'm sure there's a way to go from,
Sure.
pretty much anything go from something to C. So
it's
yeah.
it's actually, you can write in C or C++ or anything like that. It's the Arduino like proprietary language is like does the compilation and then links it with their libraries, which is what's really important. But yeah, I mean, like the idea is you could write anything that would compile to those things. Like obviously you just need to come up with a way to map it. And the problem is when you're writing things in, like, say you write like a Python program that uses requests, right? Like how do I compile that dependency to C? Like that's just, you know, really hard to do, or you need to figure out a replacement for like common libraries that people use.
Any more questions?
There's one over here.
Individual motor, and you don't want the car or whatever you're driving to, turn around, or so how good will the timing be?
Sure. The question is, for anybody who didn't hear it, how good is the timing? So if you have two Arduinos operating independently on a robot that has wheels spinning, you obviously need them to be pretty synchronized so that you can like make sure that it doesn't turn abruptly or anything like that. The timing is very accurate. I mean, it's a very simple implementation of like a monitoring thread that's sending data up and down. And then actions on an Arduino, on any hardware component like this, is going to be synchronous. So you don't have to worry about like the intricacies of like asynchronous programming with that kind of thing. The advice I give when people have like complex systems that rely on exactly precise timing like that is that you would probably want to put all of the motors on one Arduino, or like have some kind of like mechanism in the middle of all of them, like a relay or whatever, that controls like how they interact together. And so maybe and then other systems you would move to different Arduinos. So maybe you have a robot that has wheels that drives, and it also has analog sensors that is reading like distance and light and temperature. Like those two systems could be discretely separated out into different Arduinos, and you wouldn't have any issues of timing because it would just be about connectivity between the two. But the timing is very accurate. Like you don't really have to. It's not like if you're not doing anything that's really CPU intensive already, then it's pretty much instantaneous. I call it soft real time, just like the same soft real time stuff they talk about in JavaScript. So I don't actually alert, but the way that it's implemented, assuming you're doing things like right next to each other, since it's synchronous over serial, I guess there could be latency between the like when you send the command to the board and the board actually interpreting it, and I guess I don't really account for that, but and I think that's probably a limitation of the Fermata protocol. But as far as you can get to, like, assuming you're doing things right next to each other, it should be like pretty accurate.